the 10-day online international faculty development program on research methodology, statistical tools, and structural equation modeling. So this is Dr. Kaveri, Professor and Head of the Department of Corporate Secretaryship and convener of the program. So it is indeed an honor to welcome our academic community committed to deepening their knowledge and advancing collaborative scholarship. As the convener of this program, I extend my heartfelt greetings to all the faculty members and research scholars present for today's session. At this moment, let us collectively seek the blessings of Almighty for wisdom, clarity, and harmony. I kindly request everyone to remain receptive as we now listen to the Jain Mahamantra followed by Tamil Thai Valthu. A friendly welcome is the beginning of every meaningful connection. With this inspiring thought, I now request Dr. B. Karthikeyan, our dedicated faculty who worked tirelessly in coordinating the resource person and providing continuous technical support throughout these 10 days FTP, to kindly welcome the gathering and introduce the chief guest for today's session. Karthikeyan sir. Karthikeyan sir.
Yes, ma'am.
Yes.
With profound respect, I extend an official welcome to our esteemed dignitaries whose unwavering support and academic leadership continue to illuminate the initiative of this statute. It is a privilege to acknowledge our Secretary, Shri Udan Kumar Chodia, and our Associate Secretary, Shri Hemant Chodia, whose visionary direction and steadfast encouragement from the foundation upon which academic progress flourishes. I also express sincere appreciation to our principal, Dr. B. Mahavir, whose leadership continually inspires an environmental of excellence and innovation, and to our principal, Dr. S. Ananthakrishnan, whose guidance strengthens institutional growth and academic discipline. I further acknowledge our director, Dr. N. Venkatramanan, whose commitment to research and scholarly development elevates the standards of this program, and our dean, Dr. M. M. Ramya, whose academic stewardship nurtures intellectual empowerment and collaborative learning. With equal reverence, I recognize our Deputy Dean, Dr. R. Sureka, whose constant support and administrative insight contribute profoundly to the smooth execution of academic initiatives. And I extend heartfelt appreciation to the convener of this program, Dr. N. Kaveri, facilitator and assistant professor, whose dedication, meticulous planning, and tireless efforts have shaped this program with exceptional precision and purpose. With utmost privilege, we now proceed to the introduction of our esteemed chief guest. And it is my honor to invite attention as I present the academic profile, achievements, and significant contributions of our distinguished speaker, who has graciously accepted our invitation to enlighten us today. And with great respect, I now begin with the introduction. I'm honored to introduce such an eminent resource person for today's FDP, Dr. Anish Bhaskaran, Vice Principal of Saintgits College of Applied Sciences, who stands as a distinguished academician and researcher with exemplary contributions in the domain of commerce, management, data analysis, and financial studies, holding MCom, MPhil, MBA, PhD, and clearing both NET and SET. With more than 16 years of undergraduate teaching and 14 years of postgraduate teaching experience, he also established remarkable credentials as a prolific researcher, presenting numerous papers in prestigious national and international conferences and publishing in reputed journals with high impact factors, besides authoring and contributing to academic books. His research interests span accounts and taxation, budgeting, data analysis using SPSS, Tally GST and payroll, financial planning, and Excel-based analytical modeling. His professional engagements include lifetime membership in the Indian Accounting Association and REST Society for Research International. And he has been a resource person for various academic institutions and training platforms, delivering sessions on entrepreneurship, business planning, tally, green accounting, and project orientation. He has received notable recognition such as the Best E-Lecture Award, Best Paper Award, appreciation certificates from his institution and national level acknowledgements for academic contributions. His remarkable administrative and leadership roles include Head of the Department, IQC Coordinator, University Examination Coordinator, Academic Coordinator, Coursera Coordinator, External Examiner for UG and PG programs, and the organizer of national seminars. An accomplished expert with certifications in Tally, Microsoft Office, digital marketing, financial accounting, ethical leadership, and several international online programs from globally renowned universities. Dr. Anish exemplifies excellence in teaching, research, and institutional development. With such profound experience and expertise, particularly in statistical analysis, data interpretation, and SPSS applications, we are delighted to have Dr. Anil B. Bhaskaran as the resource person with us today. Thank you, sir. And now the session is yours.
Thank you, Dr. Karthikeyan, for the warm introduction. So it is indeed our privilege to have with us Dr. Anish to share his practical experience in the field of statistics and research methodology. Sir's expertise will certainly enhance our understanding and guide us in applying the right statistical tools in our research work. With immense respect, we now hand over the session to you, sir. The stage is yours.
Okay. Thank you, Dr. Kaveri and Dr. Karthikeyan. Thank you for your kind welcome. And I am pleased to be here as a resource person for statistical testing and look forward to engaging with the participants and sharing valuable insights. Before we jump in, let me tell you something very simple. In research, we always collect sample data, but the answer we want are about the population. So we need statistical tests to help us decide whether what we found in the sample is actually meaningful or just a coincidence. Let me tell you a story. A researcher once told me, Anish sir, I have the data, I even have SPSS. But every time I see that long list of tests, I freeze. She said, which one should I choose? What if I choose wrong? What if my entire research collapses? And at that moment, I realized something powerful. Statistics doesn't fail us. We fail statistics. When we don't know how simple it actually is. Today, in this session, I'm not here to teach you test. I'm here to remove your fear. I'm here to bring clarity. I'm here to show you that every test, every decision, every click has a story. And once you understand the story, statistics become effortless. Today we will cover parametric and non-parametric test, normality test, and deciding which statistical test to be considered. These are the various parametric and non-parametric tests to be applied in the social science research. I think the time is very limited, so I will go with some rush. And meanwhile, if you want to ask any clarification, you can. Okay. So shall we start?
Sir. Yes, sir.
Statistical tests are used to normally to draw conclusion or make inference about a population based on sample data. We know that the population is infinite. We cannot predict the exact movement of or the exact trend of the population by considering samples, but we are supposed to give a clear inference on the entire population. So these tests help determine whether the observed results are due to chance or represent actual differences or relationship. So statistical test normally classified into two categories. One is parametric test and second one is non-parametric test. Then what is a parametric test? So we always have a confusion what kind of parametric or what kind of non-parametric test to be used, or in what context these tests to be applied in the real research work. Now coming to parametric test, these are statistical procedure that assume specific characteristics about the population from which samples are drawn, particularly the data which follows normal distribution. You know that what is normal distribution? When you draw a curve, it simply shows a bell-shaped curve. What are the key assumptions to be considered while doing parametric testing? The data should be measured on an interval or ratio scale. It should be normally distributed. Homogeneity of variance, that is equal variance across groups to be considered. All the observations are independent. The important parametric test that we will discuss detailed, that is t-test, then ANOVA, Pearson correlation, then regression analysis, etc. The main advantages of a parametric test, that is, it is more powerful when assumptions are met. Always estimation of population parameters. It allows estimation of population parameters, mean, standard deviation, etc. And the main limitations, that is, results can be misleading if assumptions are violated. If the given data is not normal and we are applying the parametric test, it won't give the correct result for our study. Now, what is a non-parametric test? These are also known as distribution-free test, which means if the data is not normal, we can simply apply the non-parametric test, which do not assume any specific population distribution. These tests are useful when data do not meet the assumptions required for parametric test. Assumptions, or when we can use these kind of test when the data are ordinal or nominal and the sample size is very small, and if data violate normality or homogeneity. Then the important non-parametric test that we are using, chi-square test, Mann-Whitney test, Wilcoxon sign rank test, Kruskal value test, Spearman's rank correlation coefficient, etc. The main advantages of having non-parametric test, that is, it can be used for small samples. Then it can be applied when the violations of normality, and it can be applicable for ordinal or categorical data. Main limitation, it is less powerful than parametric test, and it normally provides information about the median, not about the mean or variance. Whatever may be the test that a researcher is using, it is purely depends on the type of data, sample size, and distribution. You can use parametric test when assumptions are met for greater precision and power. And you can use non-parametric test when data are not normally distributed or involve ranks or categories. Always a researcher, a good researcher, should examine data characteristics before deciding which statistical approach to use. So before selecting the appropriate test, we need to consider whether all the assumptions are met. We have to check whether the data are normal or whether all the assumptions are followed by such data. So we know that as per central limit theorem, it's a fundamental statistical principle stating that when the sample size is sufficiently large, the sampling distribution of the mean becomes approximately normal, regardless of the shape of the population distribution. That is why in majority of the thesis, we are following the parametric test, because normally we are collecting samples more than 300 or 500 as the case may be. So it assumes that that means that collected data is following central limit theorem, which means the data is assumed that data is following normality. Now, I just want to share a flowchart to you. Based on this flowchart, we need to select the appropriate test, either non-parametric analysis or a parametric analysis. This is very, very important. So I request everyone's attention, specific attention for the same. If you are able to identify or if you are able to follow this flowchart, then it is very easy for all of you to apply the same in SPSS or in manual work also. You can see, we'll start with this. Is the data frequency counts? If no, then are you looking for a difference or a relationship between scores? We'll think about first a difference. Are you comparing a mean with a single standard value? That means if you want to compare your sample, the mean of your sample with the population mean or the hypotheticated mean value, definitely you can go for different forms of test. If yes, you can go for Wilcoxon signed rank test for non-parametric test. Just consider it, if you want to find out the difference in mean, and if you want to compare with a non-value, if so, then you can apply either Wilcoxon signed test, that is absolutely a non-parametric analysis. And if your data is normal, you can apply one sample t-test. Now, are you comparing a mean with single standard value? If no, you don't know what is a population mean. If so, two aspects to be considered. Number one, whether it is applicable to same respondent or with a different respondent. If same respondent, which means either it is in a pre-stage or in a post-stage, pre-test as well as post-test can be possible. Or the same person is giving the inference for awareness and satisfaction. Such kind of variables can be studied. So a same respondent, do all the set of scores come from different respondents or same set of or some sets from the same respondent. If it is from same respondent, and we need to consider how many sets or a group if a categorical variable having two groups, say for example, gender usually have two. It can be male or female. It can be expanded. That means male, female. Then we can prefer not to say something like that. We can mention it. Means for transgenders. And if you are avoiding all that, only male and female, if you are considering, only two groups are available. If so, you can, this is for the same respondent. And if you want to make a pre as well as a post stage, pre-test as well as a post-test, or a pre-training and a post-training effectiveness, or awareness and the satisfaction of a same respondent, then you can consider Wilcoxon test or paired sample t-test. Clear? If it is 3, that means we want to consider pre, during, and post. If 3 or more situations for a same respondent to be considered, then we can apply Friedman test, that is for non-parametric and MANOVA. Normally, this is not applicable for our social science research. Now, all from different respondents, then two groups. If you're considering only two groups, that is male or female, the main difference of male and female, if you want to check, then you can go for man-Whitney test, that is non-parametric test, and parallel parametric test will be independent t-test. If your categorical variables are more than two variables, say for example, we can consider the age gap, maybe below 20, then 20 to 30, 30 to 40, 40 to 50, and above 50. So the number of groups are more than 2. In such case, we can apply ANOVA in parametric test and critical value test for non-parametric test. Now, if you want to measure the relationship, consider the variables. If two variables, you can apply Spearman R test in non-parametric analysis and Pearson test for parametric analysis. And if it is more than 3 variables, there is no non-parametric analysis, only we have a parametric analysis, that is multiple regression. Now, if the data frequency counts S, then we will go for chi-square test. If you have a cross-tabulation of two categorical variables, then two sample chi-square will be applied. That is 2 into 2 or 3 into 3 contingency table to be considered. If you are comparing observed frequency with the predicted ones, then one sample chi-square to be followed. And if you have cross-tabulation of more than two categorical variables, definitely we need to follow log linear analysis. So which kind of test to be applied to our research? This is very important. A key decision to be taken by each researcher. Knowingly or unknowingly, we are applying all these tests to our research work. That is absolutely wrong. So if you want to check your relationship, then you have to go for multiple regression analysis or simply correlation analysis, Pearson correlation. And if you want to test your main difference, of course, you have to consider whether it is for same respondent or it is from different respondent. Accordingly, you have to use or you have to choose your test. I hope you got some idea about how to decide the statistical test. We already discussed that initially we need to check the normality. whether the data is normal. So in SPSS, we can check the normality. So before going for the given sample data, so I have developed a sample data based on a questionnaire. So my questionnaire, it is factors influencing consumer behavior towards green marketing. So I have only 5 demographic variables: age, it's a ratio, then gender, it's a nominal data, educational qualification, ordinal data, monthly household income, ordinal data, place of residence, it's a nominal data. Then I have different factors: green awareness, scale question, Likert scale, 5-point scale. Then environmental consciousness, again scale data. Then green product perception. Then purchase behavior. It consists of nominal data, ratio, and nominal, then ordinal, then satisfaction, again ordinal data, scaled data, then purchase intention. So here I have green awareness factor, environmental consciousness factor, green product perception factor, then purchase behavior factors, which leads to satisfaction, and how that satisfaction leads to purchase intention of the respondent. This is only a sample data, and based on this questionnaire, I have made and I have collected the data and I have made the things in the SPSS also. So based on this data set, we will check or we will discuss parametric as well as non-parametric test. Now, we can check how this normality is checking in the SPSS. Analyze, descriptive statistics, explore, then which data to be considered. Here, I just want to consider my awareness variables. Plots, normality, histogram, once again, so here you can see that there is no bell shape. So this data is actually not normally distributed. Okay. You will get a bell-shaped curve by seeing this histogram. If it shows a bell-shaped one, then we can easily say that it is a normally distributed data. So if the significant value is greater than 0.5, then data is normal. And if the significant value is less than 0.05, then normality is violated. And based on our sample data, we are not considering the normality. We will check both test, parametric as well as non-parametric analysis. Okay. Now, moving to first statistical test. That is, if you want to compare a sample mean with a known or hypothesis value, from our question, I'm considering awareness variable, and this to be tested with a population mean of 3. my question regarding awareness, it is based on 5-point Likert scale. So the midpoint value is 3. So we need to check the perception of the respondents with regards to the awareness, whether they have lower awareness or whether they have higher awareness. Let us check. Analyze. One sample t-test. So I have 5 awareness variables. I'm giving here the test value 3. Okay. So you can consider scaling questions. You can consider satisfaction scaling questions or environmental consciousness scaling questions. Depends. So test value is 3. So this is a result of one sample t-test. See, for all the variables, significant value is 0.000. So based on this, all variables have the p-value is less than the significant value, meaning this indicates that response show high awareness, belief, and consideration toward green or eco-related concept, which means all variables are statistically significantly higher than the neutral value of 3. Now we can check how it is applicable to the non-parametric test. How can we do non-parametric test for the same case? Analyze non-parametric test, one sample. So here objective, field, settings. So in field, so test field will be the awareness variable to be considered. Once again, non-parametric test, one sample. One more thing that we have to, in settings, customized test, compare median to hypothesized Wilcoxon signed rank test. Here we have to put the value 3. Then run the test. You will get the answer. See, it is significant. The result shows that all variables returned a p-value of 0.000, which is significantly below the alpha level of 0.05. Therefore, the null hypothesis for each construct is rejected. Inference, the findings indicate that respondents exhibit strongly positive perception toward all green-related construct measured. Dear participants, whether we use a parametric or a non-parametric approach, both analyses show the same conclusion. It reports that awareness and perception significantly above the neutral level, which demonstrates a strong positive orientation toward green or eco-related ideas. So whatever may be the test that you are going to choose, it gives the same outcome. Only thing is that if the data are normal, then we can apply parametric test. And if the data violates normality, definitely we can go for non-parametric test. Now, we can go for comparing two related samples. That means comparison for the same respondent in two views, either in pre-stage or in a post-stage. If that are normal, definitely we should go for paired sample t-test. Here, I'm considering two variables, that is awareness, and second one is the perception of green marketing. Now, we'll check how these tests are conducted. Analyze, compare means, paired sample t-test. First variable is awareness, second variable is perception. The result of paired sample t-test. See here the mean of awareness, that is 4.34, perception 4.55. Its correlation is moderate one. Significant relation is showing, and here in t-test also the significant value is 0.000. So we can say that it has a moderate relationship. Higher awareness tends to relate to more positive perceptions of green marketing. If people are more aware, definitely they have a positive perception towards the green marketing concept. The respondents' perception of green marketing is significantly higher than their overall awareness. Now we will check how these analysis means how the non-parametric analysis is giving the result for the same variable. Analyze, non-parametric test, related samples. So in test field, we can consider both awareness and perception. In settings, customize a test. You can select Wilcoxon matched pair signed rank 2 samples, then run the test. You will get the result. Here the significant value is 0.00, reject the null hypothesis, which means it has there is a statistical difference. So difference between the medians is statistically significant. Hence, respondents tend to show a more favorable perception on green marketing compared to their general environmental awareness. So here also, the pair differences are normally distributed. Regardless of whether we use the parametric or non-parametric test, both methods show the same conclusion. Respondents perceive green marketing more positively than their general environmental awareness level. So here also, which statistical test, whether it is parametric or non-parametric, the outcome are same. Now, we look on to how compare two independent tests, which means we need to check the mean difference between two different groups of respondents. Okay, two different groups of respondents. if your categorical group or categorical variable having two groups, then we'll go for independent t-test as parametric test and man-Whitney u-test as non-parametric test. I will show how this analysis is done in SPSS. Analyze, compare means, independent sample test, select the test variable. Here I just want to consider the gender as one variable and satisfaction as another variable. So test variable is satisfaction of green marketing and group variable is gender. After selecting, we have to define the group. Here we have to give the value. I had given 1 as male and 2 for female. Continue and run the test. You'll get the result like this. See this, male having the mean value is 4.15, female having 4.16. And here the significant value for equal variance assumed, that is 0.83. P value is greater than the significant value. So test result P is 0.813. The result is not statistically significant. The inference shows that the independent sample t-test indicates that there is no significant difference in satisfaction toward green marketing between male and female respondent. The mean value of females are 4.16 and the mean value for males, that is 4.13. Now we will check how it is done in non-parametric analysis. What is a non-parametric analysis? Substitute non-parametric analysis, that is man-Whitney u-test. It will be done non-parametric test. Legacy dialogues, 2 independent samples. We'll consider test variable as satisfaction, grouping variable as age group, and we are defining group number 1 as 1, group 2 as 2. Then we need to select man-Whitney u-test here. This is a result given in man-Whitney test. Satisfaction of green product. Sorry, I chosen as age group. Instead of age group, we have to select gender. That's what we had given. Once again, non-parametric test, legacy dialogues, 2 independent tests. Instead of age group, gender to be selected. 1, 2, continue, selecting man-Whitney u-test. Then see satisfaction on green marketing. So here mean rank 179.34. For female, it is 172.31. Significant value is given 0.510. Now, result. Since P is greater than 0.05, the difference is not statistically significant. So this test shows that there is no significant difference in satisfaction with the green marketing between male and female respondents. See, here also in both tests, the outcome is same. Now, if a categorical variable is having more than 2 groups, in such case, we need to consider one-way ANOVA as parametric test and Kruskal values test as non-parametric test. If your categorical variables are having only 2 groups, then you can easily go for having your independent t-test or man-Whitney u-test. If your categorical variables are having more than 3 or more than 3 groups, definitely you have to apply one-way ANOVA as parametric test. Now we'll check how it is done in SPSS. Analyze, compare means, one-way ANOVA. So here we have to consider variables, that is age group and satisfaction on green marketing. 2 groups, 2 variables are, first one is satisfaction on green marketing and second one is your age group. Okay. Satisfaction, dependent list is satisfaction, and our factor is age group. Now, post hoc test to be considered, you have to select a key. Then select a descriptive. You can consider homogeneity of variance test. Continue. So these are descriptive statistics for age group. I have the age group between 18 to 27, 28 to 37, 38 to 47. See the mean value of each group. 18 to 27, 4.1057. Then for 28 to 37, 4.4167. Then 38 to 47, 4.1579. Then homogeneity variance, significant value given as 0.00. Now between groups, and here the significant value is 0.003. See, p-value is equal to 0.003, which is less than 0.05. Hence, the ANOVA is significant, which means the satisfaction with the green marketing differs across the age group. It indicates that statistically significant difference in satisfaction with the green marketing among the 3 age group. Specifically, the age group 28 to 37 shows the highest mean satisfaction. See, 28 to 37, which shows 4.4167. Now we can check how it is done in non-parametric analysis. Analyze, non-parametric test, legacy dialogues, K independent samples. Then our test variable, satisfaction. Group variable, age group. So here, maximum 1, we have 3 groups. Select Kruskal value test. If you want, you can select a descriptive, then run the test. So here, satisfaction of age group, rank 18 to 27, mean rank 172.34. 28 to 37, it is 234.17. Here also the highest rank is given for 28 to 37 age group. Then 38 to 47, it is 159.27. Now we can check here the p value is 0.005, sorry, 0.00. The difference among age group are statistically significant. In both tests, the p value is less than the significant value. The critical value test, it indicates a significant difference in satisfaction on green marketing among the 3 age groups. The age group 28 to 37 shows the highest level of satisfaction, which indicated by the highest mean rank of 234.17. Now see here also, both tests are showing the same outcome. What we have to follow, whether the data is normal or violating the normality. Okay, so now the difference tests are over. Once again, I will tell, if you want to compare the difference, then if you want to compare with the non-value, then you can go for one sample t-test as parametric analysis and Wilcoxon test for non-parametric analysis. And if you want to compare the mean with unknown value, then if you want to consider same respondent, then 2 versions are considering, then you can apply paired t-test as parametric analysis and Wilcoxon signed rank test as non-parametric analysis. Three views are considering Friedman test as non-parametric, Manove as parametric. Now different respondents, then categorical variables having 2 groups, you can apply independent t-test as parametric test and man-witness test as non-parametric test. If your categorical variables having 3 or more than 3 groups, then you can consider one-way ANOVA as parametric analysis and critical value test as non-parametric analysis. Now we will consider the relationship. If you have only 2 variables, then we can consider either Spearman test or Pearson test. Pearson test will be treated as parametric analysis and Spearman test is treated as non-parametric analysis. Let us discuss. We need to consider the variables for the study. So here, I'm taking satisfaction on green marketing and the purchase intention. Sorry. Now, analyze. Correlate. Bivariate. Variables for the study are satisfaction and purchase intention. If you want to apply parametric test, then you have to select Pearson, then run the test. So here the Pearson value for green marketing and purchase intention is given as 0.319. So it is moderately related. Clear? So p value is equal to 0.000, that is significant. Since P is less than, the correlation is statistically significant, and the value of R is 0.319, which indicates a moderate positive correlation between the two variables. The inference will be respondents who are more satisfied with the green marketing initiatives are more likely to express higher purchase intentions. Now we'll check how it is in Spearman's test. Now here, analyze same procedure, correlate, bivariate. Instead of selecting Pearson, you just select Spearman. See here, the correlation coefficient is 0.401. Significant values 0.000. It indicates a moderative positive correlation. It reveals a significant moderate positive relationship between satisfaction on green marketing and purchase intention. Here also, outcome are same, but test results are showing some differences. Whatever it is, whether the data is normal, we can select a Pearson correlation technique. If your data is not normal, then you can select the Spearman correlation technique. Now we'll move to regression analysis. Before selecting regression analysis, we need to consider some assumptions. It should follow linearity, which means the relationship between X and Y should be roughly straight without unexpected bends. Data should be normal and it should have the linearity assumption. If your linearity assumptions are violated, then the model will misunderstand, which give you the wrong picture, wrong prediction. Normally, regression analysis is done for predicting one variable based on another variable. Then another assumption, that is homoscedasticity, constant variance of errors. That is, the amount of error should stay about the same no matter what value X takes. If it is violated, the confidence intervals become less trustworthy. We cannot believe that particular model in such context. Then, independence of errors. It should not influence each other. One error cannot influence another one. Each one must stand its own without forming any particular pattern. If it is violated, we cannot judge its own accuracy properly. Okay, anyway, we have only limited time, so we need to finish all these things. So at least we have to consider linearity, homoscedasticity, independence of errors, then normality of errors. Okay, so we will discuss how a multiple regression or simple regression is done in SPSS. Both are parametric tests. Now here, the simple linear regression or multiple linear regression is applied to predicting one variable from another and predicting one sample variable from several predictors. Now we'll think about the simple linear regression analysis. Here I'm taking two variables, satisfaction on green marketing and purchase intention. We consider the same variables for measuring the correlation. There we consider how it is related each other. But in this case, simple linear regression, we are predicting one variable from another. How one unit is influencing the other variable. That's what we are discussing here. Now, it is done in SPSS. Analyze, regression, linear. Now, dependent list. Here, purchase intention and green satisfaction are two variables. So here the dependent variable is purchase intention. Based on the satisfaction, the purchase intention of the respondent are measured. Satisfaction. Then model fit estimates. You can show the model summary, that is R value, R square, etc. Then here the ANOVA value, that is significant. We'll check. Model summary which shows the R value is 0.319, R square value is 0.102, which means the model explains 10.2%, okay, of the variance in purchase intention. The regression model is statistically significant and its coefficient value is 0.264. It shows that 1 unit increase in satisfaction on green marketing, the purchase intention will increases by 0.264 units on average. It shows that the predictor is highly significant. So the simple linear regression, it shows that the satisfaction on green marketing is a significant predictor of purchase intention. If we are considering only two variables and one variable is purely predicting the value of another, then we can simply follow the simple linear regression. If we have more than one variables, if you want to find out predicting one variable from several predictors, definitely we need to consider the multiple linear regression analysis. So here I am considering the different predictors such as satisfaction, awareness, environmental consciousness, perception on green marketing, purchase behavior. 5 predictors and finding the value of purchase intention. We'll check how it is done in SPSS. Regression, linear. So independent variables will be awareness, then environmental consciousness, perception, purchase behavior, and satisfaction. 5 variables. So here the R value is 0.740, R square value is 0.548, then ANOVA value that is significant 0.000. See, the model explains 57.4% of the variance in purchase intention, which is very strong R square value, that is 57.4%. Since the p-value is less than 0.00, the 0.05, the overall regression model is significant. At least one predictor significantly explains purchase intention. So here the significant predictors are awareness, environmental consciousness. Then here we have non-significant predictors such as satisfaction, perception, and purchase behavior. See the values. Here, satisfaction on green marketing is not significant. Then awareness, significant. Environmental consciousness, significant. Perception on green marketing, not significant. Purchase behavior, significant. So the inference is given that the simple linear regression analysis shows that satisfaction on green marketing is a significant predictor of purchase intention. The model is statistically significant, which indicate that satisfaction plays a meaningful role in shaping consumers' intention to purchase. The predictor explains, the multiple regression model predicting the purchase intention was statistically significant, indicating that the combination of the 5 predictors explains a substantial portion, that is 57.4% of the variance in consumer purchase intention. It suggests that the model has strong explanatory power. Now, we'll move to comparing the observed frequencies with expected frequencies. For the same, we need to consider chi-score test. So chi-score test is normally, it is a non-parametric test. It can be applied for goodness of fit test and test of independence or association. Now, how chi-score test is done in SPSS? So for goodness of it, I'm considering the observed frequencies of preferred shopping modes. Respondent can consider online mode, offline mode, or both. So which do not differ from the expected frequencies. Simply, the preferences are equally distributed across the 3 modes. Okay, we'll check. So here, analyze, descriptive statistics, cross tab, we can consider the gender, then preferences on for goodness of test, it is non-parametric test. Legacy dialogues, chi-score test. Now here the test variables will be preference to purchase behavior, descriptive, preferred shopping. I was selected the wrong variable. So preferred shopping modes, then okay. So here online, offline, and both. See that total number of respondent 350. Out of 350, 223 are preferring both method. Only 63 are preferring offline. Only 64 are preferring online. So the preferences across the group is different now. So we'll check the test result. Chi-square value is 145.377. P-value is 0.00. It means that observed frequencies are significantly different from the expected equal distribution. It is not equally distributed. Both preference, the respondents are buying the green products in both way, offline as well as online. It is more. So goodness of it test shows a highly significant difference between observed and expected shopping mode preference for green product, which indicates that respondents do not prefer all shopping modes equally. So once again, I will give you the direction for testing the goodness of it. It's a non-parametric test, legacy dialogues, chi-square, then selecting the preferred shopping mode, then run the test. You will get the result. The observed frequency and expected frequency will be there. Now, lastly, test of independence. We need to measure the association between the variables. So here I am taking the variables as gender as well as their buying pattern. Gender and buying pattern are independent. Male and female, their buying pattern will be measured. So for measuring the test of independence, descriptive statistics, cross tab, select gender, then then their preference to purchase, so their buying pattern to be selected. This is buying pattern, statistics, select chi-square. So here their buying pattern depending on a need and a regular buying. So male 83 are buying depending on their need and 76 are making a regular purchase. Female 115 depending on their need and 76 depending means regular buying habit. Will here the chi-square value, p value is 0.132. Say 0.132. The test of independence found no significant association between gender and buying pattern, which indicates that male and female respondent do not differ significantly in whether they buy regularly or depending on need. The gender has no specific association, no significant association regarding the way of their purchase. Buying pattern of green product is not dependent on gender. Both males and females show similar tendencies regarding whether they purchase regularly or only when needed. In both cases, they show similarity in their buying pattern. This is a test for independence. It can be 2 into 2 contingencies, 3 into 3 contingencies, even 5 into 5 contingency table can be applicable based on the number of data, because while doing chi-square, no column to be left as less than 5 frequencies. So that kind of assumptions to be followed. If you are able to follow the same, definitely you can apply chi-square as a 2 into 2 or 3 into 3 or 5 into 5 contingency table. So these are the important tests that I just want to discuss with you. I know that this is not sufficient time to complete all these things. Actually, we need to get a hands-on workshop. Then only you will get a clear idea about how these tests will be applicable, how the hypothesis to be developed, and how we have to give a proper inference on each hypothesis. But I think that you have a basic idea about which kind of a test to be taken or in which way we need to make the analysis. That kind of clarity maybe you got during this session. I think so. So anyway, we will conclude with once again, we will check whether all the analysis or all the statistical tests to be considered. When we have to consider the statistical test, something like that we need to consider. So we can apply one sample t-test or Wilcoxon test for comparing sample mean or median with a non-value. We can consider paired sample t-test or Wilcoxon sign rank test. Compare two related variables. Then we can consider independent t-test or man with U test. Compare two groups. Then one-way, ANOVA or critical value test for comparing 3 or more than 3 groups. Then we can consider Pearson or Spearman test for measuring relationship between 2 variables. Then for predicting the variables, if you are considering only 2 variables, then we can consider simple linear regression. If we are considering more than two variables in the sense that more than two predictors for finding one variable, then we can go for multiple linear regression. Then for goodness of it, we can consider chi-square test as non-parametric. Then test of independence, again chi-square. So these are the important statistical tests to be considered in the social science research. So my final message to all the participants: statistics is not about numbers. It is actually making meaningful decisions with confidence. So as we come to the end of today's faculty development program, I would like to take a moment to summarize what we have accomplished and reflect on the key learning points. Over the course of this session, we explored both parametric and non-parametric statistical tests, understood when and why each test should be used, and learned how to interpret the result effectively in SPSS. Our goal was not only to understand the formulas, but to build the clarity on decision making. We began by understanding the foundations, assumptions such as normality, scale of measurement, and sample size. And we consider almost all the parametric and non-parametric tests. I sincerely hope that today's session has helped you to build confidence in selecting and applying the right statistical tools in your research. My intention was not to make statistics simple, logical, and meaningful, and to support you in transforming data into powerful insights. Before closing, I want to express my heartfelt thanks to the organizers, the institution, and all the participants. Your engagement, questions, and active participation made this session productive and enjoyable. It was truly a pleasure to interact with such enthusiastic group of faculty members. If you have any questions, need additional support, please feel free to reach out. I will be happy to assist. Thank you once again for your time, attention, wonderful participation. Wishing all the best in future research endeavors. Have a great day.
Thank you so much, sir, for that insightful and highly enriching session. So with this short time span, you have explained a lot the parametric and non-parametric state, starting from independent sample t-test to finally the chi-square test. So it is truly hard to explain, cover all these concepts in this 1 hour.
Yeah, definitely.
Because it's a 6 to 8 hours session, but you covered within a hour, sir. So,
yeah, I will share that flowchart to you, so you can share the things to all the participants. I think if the participants will get an idea about this flowchart,
sure,
definitely they can go for doing their work.
Yes, sir. Yes, sir. So our explanation have made the concepts of parametric and non-parametric tests remarkably clear and practical for all of us. I hope everyone have understood the concepts really practically also. So we truly appreciate the depth of knowledge and clarity you have shared today. And now, dear participants, it's time for the interaction. If you have any questions of today's session, please feel free to ask. This is your opportunity to engage directly with our resource person and strengthen your understanding. The floor is now open for questions. Participants, please. You can also post your questions in the chat box.
Sir, good evening.
Yeah, good evening, sir.
Sir, my question, the first one is, you explained very enlighteningly about the statistical tools which are applicable in the research. So,
yeah,
in this, you said about the Pearson's correlation coefficient, the R value is 0.312, maybe somewhere we are getting.
definitely. While doing the relationship correlation,
Yes.
Definitely one variable have relation with another variable. It may be in positive relationship or negative relationship.
Yes.
So
Yes.
that significant relationship may be high or moderate or low.
Yes. My question on that generally,
Mm.
in more than 0.5, we may be consider the relationship between the variables. If it is
Yeah.
less than 0.5, we could not consider it
There
is a
is no
good. It is a good.
statistical relationship between these
Yes.
two variables.
But you said that is a
But
moderately good.
sir, actually in correlation, the relationship is varying from
Zero
-1 to
-1 to +1.
+1. That
Yes.
means there should be some relationship between these variables. So it may be either inverse or it may be either positive relationship. Okay, somewhat
My
it will be there.
Yes, sir. Yes, sir. Yes. But my question is, can we consider 0.31 is also a good relationship, the
No,
positive relationship?
your data is normally distributed. It won't be possible actually, sir.
Okay, thank you. Another, sir,
0.31 is not a good relationship. It's a relationship, but we couldn't able to say whether it's a good relationship, a strong and positive relationship like that.
No, sir was asking about whether the test result is showing that means the p-value is greater than 0.05. So, which means your data is not good enough to test the relationship. That's what I have to.
sir, another question.
Yeah.
We are using the regression analysis.
Yeah.
Generally, if we need to apply the regression analysis, there will be some assumptions.
Yeah, definitely. Linearity should be followed.
Yes. But in the quality, whatever sir you explain the data, all the data may be a categorical.
Yeah.
Yeah, sir.
Yeah.
So in such a cases, so can we apply the regression analysis? Supposed to be you are taking the independent variable as some categories 1, 2, 3, 4. So you are
Sir,
getting
normally we have to use the scaled questions to measure the means we have to identify one variable from different predictors. So categorical variables is not fit for applying the regression analysis. You mean that maybe it can be used as means there some kind of ordinal categorical variables can be applied, income level, or all other nominal categorical variables cannot be applied.
So for regression, one variable may be a categorical or a continuous scale. For another should be a continuous scaled variable. That means a Likert scale.
Yeah, Likert scale. Yeah.
Both should. If you are applying both
No,
as
actually,
a continuous scale, that is okay. But one should be a continuous scale, and another it may be a continuous scale or maybe a categorical scale.
No, actually, dependent variable should be continuous. Actually.
Yes, sir. The dependent should be a continuous.
Continuous.
Variable.
Yeah.
Yes, sir. The independent variable, it may be a continuous or a categorical one.
Yeah, categorical. Yeah.
Yes, sir.
Thank you, sir. Myself, Dr. P. Srinivasa Rao, Visakhapatnam, Gayatri Vidya Parishad College.
So one more question is there in the chat box. So it's Professor Jeevita. What she asked, how to group the variables. That is our question. Yes, sir.
How to group the variables.
Yes.
Actually, that session was taken by yesterday itself.
Yesterday session.
Yeah.
Unfortunately, it has been postponed, sir.
So grouping variable, that means here the data view, variable view, this is very, very important, how all these data is grouped. So I cannot give an exact answer in 1 minute. So depending on the category, maybe the nominal data, ordinal data, or even ratio data, accordingly we have to. So this is a way in which we should consider. Say if it is age, then it can be, we can give the values accordingly, or descriptive statistics can be considered. And if it is gender, the group can be male or female. So here you can see male and female can be given. For male, the value is 1. For female, it is 2. Then for education, it can be school, diploma, undergraduate, postgraduate, doctoral. This is based on my questionnaire. So I had given 1 as school, 2 for diploma, 3 for undergraduate, 4 for postgraduate, 5 for doctoral degree. So entering data into SPSS, it needs special attention and it needs another 1 hour to complete all these things.
Yes, sir. Yes,
Yeah.
sir. Jita, ma'am, this will be explained on the December 4. The yesterday's session will be that has been postponed to December 4. And while grouping the variable, first we have to enter the data and we have to give the dummy numbers to the variables.
Yeah.
After we have to group it accordingly. So it took 1 hour time to explain all these things. I think you will get the answer on December 4, ma'am. Yes, so one more question is there, sir.
Yeah.
Is there the same results for multiple regression and structural equation modeling?
Sir, actually, structural equation model is the combination of the multiple regression analysis and the confirmative analysis. Okay. That means we are actually validating the entire thesis. So it is a combination of multiple regression and the confirmative analysis. It's an end result of these two applications. Somewhat it is related actually.
Yes, sir. Somewhat it is related based on the standardized coefficient
Yeah,
and
exactly.
unstandardized coefficient.
We have to make a confirmative analysis first, and then we can apply. Means we can find out the correlation between all the variables to means all the predictors to one variable, and outcome of these two will be called structural equation modeling.
Finally, the conceptual framework is
Exactly,
explained
exactly.
in the structural equation modeling,
Exactly.
but that is not totally equal to the multiple
No,
regression.
never.
It is somewhat.
It is only validating the entire thesis.
Yes, sir. Yes, sir.
And actually, SEM is not a specific tool.
Sure, sir. Yes, sir. Sir, I have a question, sir. Shall I, sir?
Yeah, okay.
Yes, sir. In our research, when even the sample size is large, and we people often prefer the non-parametric test like chi-square test or Friedman test.
Yeah.
So instead going for the parametric test. So could you please explain why the non-parametric tests are chosen in such cases?
Actually, ma'am, as per central limit theorem, if your sample size is large, actually, then it tends to be shows the normality. So we can follow the parametric test.
Because mostly it is quite easy to go with the chi-square test and the Friedman test instead going for the rank correlation and all.
Friedman test actually it's a non-parametric test. It is normally
instead of ranking we are using the
Friedman.
Yeah,
it is normally applicable for same respondents, different views, more than three views to be considered. So, for example, if you are conducting some training program. So prior to that, we have to
apply that for rating scaled questions. If they are giving the rating or ranking to the questions, you can go with
that's for different occasions, ma'am. For same respondent, how same respondent is giving their response to 3 different occasions, then we can apply for Friedman test.
Yes, sir. So, any other questions? Any other questions from the participants? Yes, thank you, sir. Thank you, sir, for clarifying the doubts of our participants. So it is now time for the photo session. It's already too late. We request all participants to kindly switch on your camera so that we can capture a group photo, please. Karthikeyan, sir, are you there?
Sir, it was a very wonderful session, sir.
Yes,
Thank you so much, sir. Really helped us a lot.
Thank you.
It is too hard to cover all these things within this 1 hour.
Yeah, and that, ma'am, actually it needs a hands-on workshop.
Yes, sir,
offline it requires actually.
One day is required for this. Yes.
1 day is, I think, sometimes it is sufficient.
Yes, sir.
Because while doing hands-on workshop, we have to explain all the assumptions and development of hypothesis for each cases, something like that. So it needs at least 2 days.
Yes. Karthikeyan, sir, is that over?
Yes, ma'am.
Yes, sir. Thank you. Thank you all. Yes, gratitude is not only the greatest of virtues, but the parent of all others. With these words, we come to the end of the today's session. I now invite Dr. B. Karthikeyan to deliver the vote of thanks.
It is my privilege to deliver the vote of thanks on this meaningful occasion as we bring to the conclusion of the day 6 of online international faculty development program on research methodology, statistical tool and structural equation model. And I extend my sincere gratitude to our respected secretary Sri Udan Kumar Chotia for his inspiring guidance that consistently strengthens academic development, followed by heartfelt thanks to our associate secretary Sri Hemant P. Chordia for his continued encouragement and strong support for research oriented initiatives. And I offer respectful appreciation to our principal, Dr. V. Mahavir, for his motivating leadership and constant academic reinforcement. And I record my thanks to our Vice Principal, Dr. S. Ananthakrishnan, for his valuable guidance and administrative support that enhanced the smooth conduct of this program. And I acknowledge with gratitude our beloved Director, Dr. N. Venkatramanan, for his constructive direction and positive involvement. And I appreciate the contribution of our Dean, Dr. M. Ramya, for her supportive role and academic coordination. And I thank our Deputy Dean, Dr. R. Sureka, for her consistent administrative assistance, which ensured seamless arrangements. And I convey my special thanks to our convener, Dr. M. Kaveri, for her dedicated efforts and meticulous planning that shaped the success of this FTP. And with deep respect, I extend warm appreciation to our distinguished resource person, Dr. ANISH Bhaskaran, Vice Principal, Saintgits College of Applied Sciences, for his insightful session and valuable academic contribution that enriched the learning experience. Thank you all.
Yes, participants, thank you all for your active participation and engagement throughout the session. We appreciate your commitment to learning and look forward to seeing the same energy in the upcoming sessions. Thank you. Thank you all.
Thank you, ma'am.